Hello and welcome to the TypeScript Basics course with me, Todd Motto. In this course we're going to take a real nice dive into TypeScript and how we can use it and think in TypeScript terms and also apply it to our code base. After this course you'll have a great understanding of how to use TypeScript and you can jump straight in and start refactoring perhaps old JavaScript applications and also diving into new TypeScript applications. What we're going to start with is diving through the basic types of TypeScript, and then we're gradually going to progress into some of the more advanced topics, where we want to learn about things such as inheritance and classes and constructors and all these types of things, and how we can apply a more sensible approach to our apps using TypeScript. So before we dive in, I want to take a quick look at and answer the question, what is TypeScript? Why should we even add this to our projects? Where did it come from? And what are the motivations of the project? So first things first, you may or may not know, TypeScript is actually created and maintained by Microsoft. Now TypeScript is famous for its static type system, and these things don't actually live in JavaScript. In JavaScript we have dynamic types, it's a dynamically typed language, and we can assign any kind of variables to it, and I'm sure that in the past you've experienced some kind of bug, and it's been because of a type has been wrongly assigned, such as a string has been attached to a number, or you're passing the wrong arguments through a function. Now, as you actually code in TypeScript, TypeScript will tell you that you're doing things wrong as we actually type and build out our applications. So this is one of the great benefits. And if you're using a great text editor, we'll also see some big help there. One of the most important things to remember, and you've probably encountered ES6, or what we call ES6 or ES 2015, and we also have 2016 and 17 and so forth, and each year we have some updated features in the JavaScript language. So you can think of all these as a superset of ES5. We've been probably using ES5 for years and years, and then ES6 came along and gave us a great new feature set. Now, any ES5 code is completely valid JavaScript, as is ES6 code is completely valid JavaScript. And you can create this same approach with TypeScript. TypeScript is just a superset of JavaScript. It allows us to write perfectly valid JavaScript applications. But the big difference is it provides us with static typing. Now, when I first started looking and using TypeScript, I was really unsure about whether I wanted to actually use TypeScript. And it took me a few trials and errors, and I couldn't quite understand it. And finally, after a few days, it all clicked for me as I was applying it to my applications. My errors were getting less, my code was being more structured, and the addition of types has helped me every single day. And I hope after this course, it will also help you understand TypeScript in a lot more detail, and you'll be able to apply completely new thinking when building even pure JavaScript applications. It doesn't have to be some kind of framework project, it could be with Node.js and these types of things. Now, one of the great features of TypeScript is we get IDE support. So if you're using something like VS Code, such as myself, if you do something wrong or assign an incorrect type to a particular variable, Types is going to tell you straight away. It's going to say, hey, you're not allowed to assign this to this because you told me that this was going to be of type string, and you're telling me that you're now giving me a number. So these things help us on our journey to creating more robust software. And this is what it's all about. It's creating that maintainable software and creating less bugs. Now, one of the great things about TypeScript is its support for new, and we'll call these ECMAScript features, because ECMAScript is the official language and JavaScript is the implementation. And we get these brand new features given to us potentially overnight. So as soon as a new ECMAScript feature potentially comes out of the process, where after it's gone through various stages and it finally becomes supported in JavaScript, then we get those types of features right away. But we also get some of the features that aren't supported right away. Things like decorators, and we get things like interfaces and obviously types. And these things don't exist in JavaScript. This is the whole reason that TypeScript exists. So now we've kind of looked at what is TypeScript, we need to look at why should we adopt TypeScript. And I've mentioned a few of these already. So TypeScript, it gives us essentially typed JavaScript. Now, for one, this is a very good thing, and I think by the end of the course you'll understand this as well. And it also gives us a much better code quality, and it gives us better code understanding. More importantly, and one of the greatest things about TypeScript, is it also acts as documentation. Now, how does this work? So let's assume that you've just joined a new project at your workplace or team member, for example, who you're working on a project with, and there's lots and lots of code and you have to go through all the functions to work out how these things work. And it might be that at face value, we look at a function signature and we see arguments A, we see arguments B, but there's nothing telling us what's coming into the function. We don't know what the types of the arguments are meant to be, how we're meant to supply them, are they optional, and these types of things. By the end of this course, you'll be able to see how TypeScript does this for us. It doesn't produce documentation, but we can get it to, but by just looking at the typed code, and we can hover over our function definitions and variables, and we can instantly see what they are doing for us. TypeScript also has something called type inference. So we could optionally just simply assign a number to a variable, and then underneath we could assign a string, and TypeScript will immediately have inferred that number type and say, you can't assign a string to this number. Now this is just one of the features, and you'll see the more powerful side of this as we continue. Now, types with TypeScript are called structural types. In other languages, we have this as well, and this mainly comes down to semantics. TypeScript makes it easier for us to actually pick up a new project because duck typing with TypeScript is a first-class language construct, which means that we can describe how something looks and then attach it to perhaps a function or a variable. And that description that we gave it with TypeScript is then read by the TypeScript compiler and says, the shape of the potentially object or a function that you've given me doesn't match what you told me it was going to look like. So TypeScript gives us the benefits of this. Now I've mentioned ECMAScript features, and we'll cover this in the next video in a little more detail, but we get brand new ECMAScript features, and we can use things like async await and new JavaScript APIs that are constantly coming out and evolving before us. So I hope this is a good introduction for you for the course, and I'm really excited to teach you about TypeScript. And if it's your first time dealing with TypeScript, then I think at the end of the course, you're going to love TypeScript. So I'll see you as we continue through the course. And in the next video, we're going to talk about some of those new JavaScript features in a little more detail so we can see what we have at our disposal. So let's talk about TypeScript and JavaScript in a little bit more detail before we get started with the course. So let's look at the difference between TypeScript and JavaScript. And we'll also think about this visually with a small diagram which will just explain things a little further. We'll also look at some of the features that have been added to JavaScript which are also available to us in TypeScript. So first things first, I've got this quote from the actual TypeScript documentation. TypeScript is a typed superset of JavaScript that compiles to plain JavaScript. So this is one of the most important things to remember. Any TypeScript that we write, and we will write throughout this entire course, is in fact just going to compile all the way down to JavaScript. So the way that we can think about this is the JavaScript that we do write, or the JavaScript that we want to write daily, is in fact going to be the same code that we write with TypeScript. TypeScript is just a superset, which means that it gives us a few more features, but it gives us all of the capabilities of JavaScript. And those new features are going to be compiled, and the key word is compiled here because we need to run something called the TypeScript compiler. Now we'll deal with this in the next couple of videos as well, but the TypeScript compiler will take our TypeScript files and then convert them, essentially. It's a transformation process into JavaScript. That JavaScript file then gets served up in our browser in any way that we want, or in fact it could be served up to use on a node server. So there's lots of use cases for using TypeScript, but it's good to understand that it compiles down to just plain JavaScript. And one of the great things is, for instance, we can say to TypeScript that we want to compile down to different versions of the JavaScript language. We could compile to newer versions, or we could compile to older versions to support some of the older browsers. So depending on the applications that you build, if you're building for perhaps an old Internet Explorer browser, you might need to compile back a little bit further, and TypeScript will do this automatically for you. Now, if you're using something such as Node.js, Node supports a lot of ES6 features, but we don't really need to worry about that too much with Node.js. Some of the key points to remember are all of the ES5, the ES6, and beyond features are available in TypeScript, and you can jump into TypeScript's website, the documentation, and look at the what's new. You can see the different versions, you can expand them, and it will tell you what they've recently added to the language. And this might be something that comes from JavaScript itself. It could be inspired by the JavaScript language, or TypeScript has come up with a new idea that makes it easy for us to implement. And upgrading TypeScript is actually really easy as well. So TypeScript's got lots of features. We'll be covering this in depth in this course. And there's also the next course, the TypeScript Masterclass, where we'll dive a little bit further and beyond as well to continue that learning process. So I mentioned that we want to visually think about TypeScript. And if it hasn't kind of clicked at you already, this is a great diagram to represent what's happening. So we usually have ES5 in the middle. These are the older JavaScript constructs that we might use. We could think about even older versions, such as ES3, for example. And ES5 introduced some great new things, such as .map and .for_each. And then we had ES6, where we have arrow functions and let and const and async and await and all these brilliant features. Now TypeScript, as you can see, encapsulates all of that. So any version of the JavaScript language that you write is also available in TypeScript. Any TypeScript that we write is valid JavaScript. That's a great thing to remember. So last but not least, let's have a look at some of the ES6 features and ES7 and beyond that are available to us in TypeScript. Now, in the next chapter, we'll actually be diving through quite a lot of these in more detail, but it's good to just kind of think about these up front. So we have imports and exports. This is a great addition to JavaScript. It allows us to not use things such as module patterns and worrying about the order of execution. And we can then request perhaps a function or a variable from a completely different file without having to manually worry about the order in which it was declared and these types of things. So imports and exports are super powerful, and we'll cover the basics because there's not really much to it besides the basics in the next couple of videos. And we'll also talk about things such as arrow functions and shorthand arrow functions and how the this keyword ties into it as well. We'll also be looking at function parameters, so these are great new things, and they tie into TypeScript nicely because we also get the ability to create an optional function parameter, and TypeScript can pick this up for us. So we'll be exploring this throughout the course as well. And if you haven't come across what we call the spread operator, that ... which is one of the most powerful features, and I absolutely love it, we'll be covering the spread operator, which we typically use with arrays and objects. And this ties into immutable patterns, perhaps for cloning objects or spreading new items into an array. We'll also be covering destructuring, and this is a way that we can essentially take properties out of an object or ask for values from an array. And this is also a really powerful approach. We also have object literal enhancements. We'll be covering all of these in the course, not just only in the intro chapter, but also as we continue through the course. We'll be incrementally applying things that we learn. Now, there's lots more things that we can look forward to in ES6 and TypeScript, and we'll do a nice introduction in the next chapter of some of those new features, and then we'll take a headfirst dive into TypeScript itself. We'll start looking at the primitive types, the special types in TypeScript, and then we'll build out some real examples that will help solidify the knowledge, and you'll have all the source code to take away as well. So I'll see you in the next chapter, and we'll get started with some TypeScript. So let's have a quick look at the TypeScript Basics project seed. What we actually have in here is an index.html. It's pretty simple. We don't have anything complex inside of here. We're not going to be dealing with any complex application structure. We're just going to be dealing with plain TypeScript for this course. So what we actually have inside of here is just a div, which we'll be using later on. And we also have this script tag, which we're including a reference to a file in a dist directory and an app.js file. So this is quite important, and it's quite interesting because what we're actually going to do is compile our TypeScript file in here out into a JS file. Now, TypeScript does not run in the browser. We can use TypeScript's in-browser compiler if we want to, but it's not recommended, and it's difficult to kind of tie these things in with a production application. So ideally, we should use this as a build step, a development step, and we should use the TypeScript compiler as we develop. Now, if you're used to something like Angular, for example, we'll be using TypeScript all the time, and we'll be building Angular projects with pure TypeScript. And these are then typically served via one great big file where we have a bundle, which may pull in other bundles lazily. So what we're going to do is just have a quick walk through and have a look in this source folder. Now at the moment, all we have in here is a simple console log, hello TypeScript, and we also have a readme and a package.json. So let's open the package.json up and just have a look at what we've got in here. Now we have this scripts property. So when we run, for example, an npm run start or a yarn start, this is actually going to call our Webpack dev server. Now we don't actually have a Webpack dev server set up. We'll be doing this across the next few videos where we dive into Webpack. But for this, what we're going to actually learn is how to set up this project and install TypeScript. And then we can then play with other dependencies. So here we've got things like the awesome TypeScript loader, which if you haven't looked at yet, we'll come on to explain this when we get there. And we also have another dev dependency of TypeScript itself. And we also have Webpack and the Webpack development server. So that's pretty much it. That's all we're going to be using throughout this course. That's all we need. So we can go ahead and dive across to the GitHub repository where we can then go and download this project because you'll be using it to follow along in this course and build out the examples as we go along. So if you want to jump across to github.com/ultimateangular and /TypeScript-basics, you'll find this project seed, which we'll be using. And I've just shown you everything that's inside here. We've got a git ignore, we've got the readme, index.html. There's a few prerequisites that we can go ahead and install if you haven't got these already. Things such as Node.js. And we've also got some helpers here of how to install TypeScript globally, because we can use the TypeScript compiler outside of things like Webpack, but we can also use it locally to a project as well. So this is really interesting, and we'll actually demo this once we've got things installed. So go ahead and go and grab that project seed. You can also navigate across to the README files in this course, and you'll find the links to this particular seed project. If you've got a GitHub account, you can go ahead and hit the fork button and just fork that to your account. You can then push any changes you like to your own personal account, or alternatively, you can hit this clone or download button and just go ahead and download that zip if you want to. So we got a couple of options. Well, once you've got it installed, we'll go back and actually work out real quickly, and we'll get started with the TypeScript compiler right away. So once you've got the seed project available on your machine, you could do a few things. You could use yarn if you want to. We'll keep this simple and just say npm install -g for global, and then we're going to go ahead and just install TypeScript. Now this will actually install TypeScript globally on our machine. So when we go ahead and hit enter, we can go and grab all those dependencies, and you can see here that we've just installed this thing in here called TSC. Now this is in the root of our Node modules on my machine, and it will also do the same for you as well. Now this TSC actually stands for TypeScript compiler. TypeScript is a compiler, and we just simply need to work out how to install that compiler and then be able to run the compiler against our code. And this is pretty much it. If we want to, we can actually run TSC and just see some of the options that we have. So there are a lot of options that we can actually run. What we're going to do is learn how to set up TSC directly, and we're going to compile this app.ts. And then afterwards, we're going to look at how we can do this automatically with Webpack. And we get the beauty of things like live reload and automatic recompile of our application. So what I'm going to do first is just show you some of the basics of the TSC, which is the command line tool for actually dealing with TypeScript. So we've run TSC already. I'm going to just hit -version. So this will actually say the version is currently 2.6.2 at the time of this recording, but we want to obviously run this against our source directory because in our index.html, we actually have a dist folder which then holds an app.js. So how can we achieve this with the TypeScript compiler directly? So this is quite interesting because what we're actually going to generate is something called a tsconfig.json, which you can see here we have all of these different flags that we can pass into the CLI. However, this might get slightly repetitive. You might not remember all of the commands that we want to particularly provide to the TypeScript compiler. And much like a package.json, we also have a tsconfig.json, which holds some similar setup values. So let's go ahead and run tsc --init. All you need to do is just simply hit enter, and it successfully creates that tsconfig file. So let's dive in here and just have a quick look at what it gives us. I'll hide the terminal just for a moment so we can see what the basic options of our compiler options are. So the compiler options are things that we can specify in this tsconfig.json that when we run any tsc commands, they'll actually get picked up. And the TypeScript compiler will have a look at this tsconfig and say, this is how we're going to output the JavaScript based on my TypeScript compiler options. So what I'm going to do is just remove some of these comments. We can blow away some of these comments. You can leave yours as is if you like. I'm going to just remove these just to keep things nice and clean. We can remove everything down to here. We've got strict type checking options, which we'll cover in a bit more detail as we continue. Now we want to leave this strict of true in, so I'm going to go ahead and just remove this. And anything below this, we don't need right now. So I'm going to go ahead and blow this away as well. So ideally, we should just end up with our nice compiler options property with a target of ES5, module, CommonJS, strict of true. That's all we need. So while we're here, we might as well talk about what some of these things do. Now the target property actually allows us to specify what language or what version of the JavaScript language that we want to essentially compile our TypeScript down to. Now ES5 is short for ECMAScript 5, which we've been using for years and years. Now, we've probably heard of ES6, and we covered this in the introductory videos where we talked about how ES6 was a superset of ES5, and TypeScript was then a superset of ES6. So if we wanted to, and you can see that we hover over here, we have all these different values which we can then change this ES5 to. It's quite a common practice that we just keep things as ES5, and as browser support for new JavaScript technologies continues, one day we'll be able to just leave this as ES 2016, ES 2017, and so forth. We also have the module. So we've got various module formats, and if you're dealing with things such as Node.js, you'll be frequently dealing with things like the require. Now require is a CommonJS. We have also AMD, System.js. We also have UMD for Universal Module Definitions, ES 2015, or ES Next. So we're going to leave this as just the CommonJS. We want to keep things nice and simple, and this is mostly what we'll be dealing with. Now the strict we'll come on to in a later chapter. So once you're done here, we can simply just save this out. And we'll close off the file and just open up that terminal again. So this is where things get quite interesting because we have this app.ts with just a console log inside. We've got hello TypeScript. We want to simply actually compile this out for our index to be able to consume it in a real world application. So how do we go about transforming our TypeScript code into this dist/app.js now that we've specified a few options in our TypeScript configuration file? Now what we could do right away is actually run TSC on its own, and we'll see here that we've just generated an app.js. And that's pretty much it. That was nice and simple. We can open up this. We have this use strict, which you may have seen before, and this enables strict mode in our JavaScript. We also have our plain old console log hello TypeScript. Now the interesting thing here is we've actually failed at our task of providing some kind of dist directory. We're actually compiling it straight into this app.js. So how do we go about specifying some kind of folder that we want to actually provide? Now what I'm going to do is go ahead and just remove this app.js file, and we'll jump back down into our terminal. Now we mentioned that the TSC, you can use it on the command line, but it's kind of good practice to put everything inside this tsconfig. So what we're actually going to do, just to demonstrate the command line a little bit further, is we'll do tsc and we'll do out dir, which stands for out directory. Where do we want to compile our code and basically put it? And we're just going to specify a folder name of dist. So we'll go ahead and just hit enter and see what happens here. And there we go. We have in our sidebar, we now have that dist, and we have an app.js inside it. So we've kind of successfully, at this point, we've completed the mission of compiling our first TypeScript application, even though it's just a console log. But this is kind of an important step that we need to grasp of how the TypeScript compiler can interact with our code. So now that we've actually specified the TSC with the out directory of dist, this is kind of something that we've now achieved. So it does actually make sense that now that this is how we want to build our project, we're going to jump into our TS config again. Now underneath the strict, what I'm going to do is add that exact property, out directory, and dist. So we can save this out, we can go ahead and just remove this dist folder, and we can just run TSC on its own now, because it's going to essentially use this exact flag, but instead we are supplying those values in the compiler options of our JSON file. So let's go ahead and just run this. Again, we have that dist with the app.js inside. So that's pretty much it for achieving our mission. And there's one more thing that I actually want to show you on this TypeScript compiler. Now, because we've actually specified all of our compiler options that we need right now, what we're going to do is enable the TypeScript compiler's watch mode. So for this, and this is really simple, we can do tsc-w, or you can type watch on its own. So we'll go ahead and hit enter, and we can see here that we have compilation complete, and we're watching for new file changes. So this actually means when we dive back into a TypeScript file, we can actually change this over to hey TypeScript. We'll hit save, and if you watch the command line here, you can see that the file change was detected, and we've then recompiled those changes. So what does this mean? It means that our app.js now is recompiled via the TypeScript compiler because it's watching those TS files, and it's automatically detecting changes, and it will recompile it on the fly. Now this is great, but it might be a good idea for us to have some kind of local server where we can live reload our application as we're actually developing. So we'll be covering this in the next video when we go ahead and set up Webpack. I mentioned earlier that we're going to be using Webpack for the remainder of this course. So what we're going to do in this video is set up a basic Webpack configuration file, which will just take care of compiling our TypeScript and a local dev server, and it will also keep an eye on those changes. When we change something in our TypeScript file, everything will then go ahead and just recompile out nicely. So what we're going to do is jump straight in, and we'll just create a new file, and we'll call this the webpack.config.js. So inside of here, all we want to do is use a module.exports, and we can just assign an empty object. Now, if you haven't used Webpack before, or if you have used Webpack before, we can set up a few things to instruct Webpack on how to compile our application. So what we're going to do first of all is we need to actually create a property called entry. So this entry property then points to where we want to compile those TypeScript files. So in our case, this lives in the source directory, and we have this app.ts. So this is our entry file, and we can use things like ES6 imports and exports, and we can import them into different files, and everything will then get compiled out into an output file. So this is the next step, is actually setting up that output, and we can then pass a value of an object. Now the output can then take a file name. We'll call this the app.js because that's what our index.html file is looking for, and we also want to supply it a path. Now this is essentially the path of the directory of what we want to create. So inside of here we can say underscore underscore, and this is called the dir name, or the directory name. Now this is a global variable that is supplied via node when we actually run our Webpack configuration. So this will be supplied for us, and we can just simply append our dist folder on the end. And that's all we need to do for the output. Then we're going to tell Webpack what to resolve and the type of extensions that we want to resolve. Now the extensions takes an array. We obviously want to look at our TypeScript files, and we also need to supply the .js files. Underneath here, we can then go ahead. We're going to say module, and for this particular module, we're going to have a few rules. Now the rules is an array where we can then supply what we call different loaders to test against particular file extensions. So what we're in theory is doing is testing against TypeScript files, and then we're going to supply it a loader, which it can then compile those files. And using Webpack, we get the benefit of it being a bundler, so we can take care of all of our modules, because at the moment, imports and exports statements don't actually work in the browser. So we need to actually bundle these up, and using Webpack, it does it all for us out of the box. As the first rule, we're going to create an empty object, and we're going to say, I want to test, and here is where we supply a regular expression. Now we're going to use a backslash and a full stop, and you can see that the syntax highlighting is now picked up that this is in fact a regular expression. And we're going to say we just want to look for TypeScript files, and we can use the dollar to then denote that this will be the end of the file name or the end of the string that we are then testing against. Now the second property is the loaders that we want to supply. We can say use, and in this case we're going to say awesome TypeScript dash loader. Now this is inside our package.json. If we have a quick look and scroll down here, we've got this awesome TypeScript loader package. And you can see that this is essentially just a TypeScript loader for Webpack. So we don't have to use TSC directly. This takes care of a lot of nice things under the hood for us. And it will also automatically pick up on our TS config. So this is really nice to kind of use side by side with Webpack. So we'll go back to our configuration. And there's one more thing that we want to set up underneath this module, and it's actually to supply a development server. All we need to do here is say I want the port to be port number 3000. You can change this to whatever you like. I'm going to keep mine as 3000. So that's pretty much it for our Webpack configuration. I've just saved this out, and I'm actually using Prettier here, which is automatically formatting my JavaScript and my TypeScript files for me. So I'd recommend that you actually install Prettier as well. It's really good for code consistency across your teams. And it also adds in things like the odd missing semicolon. So if I delete this, for example, and hit save again, you can see that that's just added that back in for me. So there's lots of things out of the box which Prettier actually gives us that are really beneficial when working with JavaScript and TypeScript. So now that we've got our Webpack configuration, we want to kind of install these dev dependencies. We've got the awesome TypeScript loader. We've got TypeScript itself, which will actually create a local dependency of TypeScript. So technically, we don't need this global installation of TypeScript anymore, which we use when we're running TSC. So we're installing a local TypeScript project, and we can also control the version of each local TypeScript project. Now this is really nice because if I just demonstrate here, we'll jump into our TypeScript file, and down here you can see 2.6.2. So what I can actually do is switch different versions, and different projects might have different TypeScript versions. And there may be a breaking change or a feature change that isn't allowing you to just upgrade just yet. So it's sometimes nice that we can actually run all of these in individual projects. So what we're going to do now that we've kind of taken a look at our dev dependencies, we can close off our files, and I'm going to open up my terminal. And all we need to do, if you're running npm, you can run an npm install. What I like to use is yarn. It's a little bit faster, and I like the API, so I'm just going to go ahead and run a yarn install instead. So this will then create a lock file. It will download those dependencies for us, and we can then use something like a yarn start, which we looked at earlier when we actually talked about this project, because in our package.json, we have this script property with a start command, which then runs our Webpack dev server. Now there's a few things that are quite interesting with Webpack, and that's if we go and have a look inside our config, this output is completely virtual. It's not creating an output like our dist folder is directly with the TSC compiler. So with the TSC, when we run, we've obviously seen that this then creates this dist app.js, and we don't actually need this anymore with Webpack. So what it's actually going to do is compile our entry file and the TypeScript files, and then it's going to put them in a virtual dist folder. From there, Webpack will then go ahead and actually serve up our application. Now this is also interesting because inside of our index.ts, we don't actually need this dist anymore because it's just a virtual. Webpack will then cleverly and intelligently serve this for us, so we don't need to actually specify different folders. And this again is another benefit of using Webpack over the TSC compiler directly. We still get the benefit of using tsconfig, so ideally we should use something like Webpack. It bundles all our modules together, and it also keeps the dist directories and all these types of things are compiled outputs out of our source code and out of the actual tree views in our text editors. So I'm going to go ahead and save the index and close it off. We know that this is now virtually using the machine, and it will then serve this app.js as a base for our application. So at this point, we can go ahead and run a yarn start. Now you can see, hopefully we've got a load of green lights and everything's good to go. And we can scroll up and just take a quick look at some of the output that Webpack is giving us. So here we've got our app.js, and this is another reason that I like to use the Webpack, is it gives us some more information about our different bundles for our applications, and also you can see the size of our application here. When we want to do things like code splitting, Webpack will also tell us how many chunks our application does have. We also have some further information. We'll come onto this momentarily when we take a look in the browser, but we'll scroll up and just take a look at some further information. And you can see here that we have this project is running at localhost 3000. And like I mentioned, the Webpack output is then served from /, which again is why we don't need to specify that dist folder inside the index.html. So we're pretty much good to go. We've got our Webpack sorted. And what I'm going to do just to demonstrate a few things, what I'm going to do is change the hey. We'll just call this one Ahoy TypeScript. We're going to go and save this out. And you can see that my terminal just recompiled that very, very quickly. And we also get the benefit of Webpack's development server. So this is going to live reload and recompile. It's going to detect those changes. And it will also print out any TypeScript errors in the actual console itself. So we're pretty much done here. Let's dive across to the browser and take a look at what we have. So in the browser, we have our localhost 3000, and we also have this Ahoy TypeScript. Anytime that we recompile, this will automatically live reload itself. So every time we make a change, we don't have to keep refreshing the page manually over and over again. So in this video, we have got our project base finalized. We've got our TS config, we've got our Webpack config, we've got the yarn lock files, we've installed the dependencies, and we've also set up our Webpack configuration file, which then serves up our TypeScript project. And we use the awesome TypeScript loader to detect our TypeScript files, and then we just simply serve this up on localhost 3000. So let's dive into arrow functions. What I'm going to do first is set up some data. I'm going to call this the constant of pizzas. We're not going to change this data structure. We're going to say name is going to be pepperoni, and we'll just simply add a toppings array. We're just going to add that one topping as you'd expect with pepperoni. Now, an arrow function is really, really nice, and it can shorten your code base by quite a lot. There's two things in arrow functions that we want to look at. There's the arrow function itself and the difference between a function and an arrow function. And then there's also a special kind of arrow function called an implicit return. Now, there's not a huge difference between the two, but we'll explain this as we go. We also get benefits with scoping. So typically in JavaScript functions, we have the this keyword. Now, the this keyword is probably the most important thing to understand when you're dealing with classes or objects and these kind of things. And arrow functions make this a lot simpler. Typically, we would do something like var self or var this or var that equals this, these types of things, and we cache the variable of this, and then we reference it perhaps inside a set timeout, for example. What we'll do is build a demonstration to show you how we can use an arrow function to overcome these things as well. So first things first, let's create a function. What we're going to do is map over our pizzas. We're going to use pizzas.map, and then we're just going to simply pass in a function as you'd expect, which gives us each particular pizza. And inside of the map, we could then do something with the pizza. We could say return pizza, and we could just return the name, and we could just call uppercase. So what we're actually going to get, we'll call this the mapped pizzas equals, and then we'll log it out below, and we'll pass in our mapped pizzas. So before we go any further, and you can see that this is just reformatted because I'm using Prettier, which I mentioned earlier. I've got this installed, which just formats things based on things like the line length, and it adds missing semicolons and so forth. So let's get back to it and compile our TSC. Then we're going to compile node. So you can see here that we have pepperoni, and that's nicely been formatted to uppercase. We're not even copying the toppings across. We don't need to worry about those. Now an arrow function, let's go ahead and build out this example a bit more. We can actually delete the function keyword altogether. It might be that we have something so simple inside of this map that we can just simply use an arrow function on its own. And to me, immediately this looks a bit clearer. If we're not dealing with things like the this keyword, it can make perfect sense to just go ahead straight away and start using an arrow function. And these things are really common, and I see other developers using this approach as well. Now, an arrow function is really cool, and we can actually pass in different properties. So the second argument, we get the value, and you can see here that I'm getting this function definition, this callback function, and we also get the value, and we also get the index. So here I could actually write index, and we could log out the index inside of our map. This is how the array prototype map method works. Now, if we've got multiple arguments with an arrow function, we definitely need these brackets either side. If, for example, we only have one argument, we don't actually need to supply them. So we could leave it completely on its own, and it works out nicely like so. Now, I also mentioned that we have another kind of arrow function called the implicit return. So you can see here that I'm using the return keyword. So this is great, and this is a common pattern. We typically have an array, we get the value, we define the function, we create the curly brace, and then we do something inside and then just return it. Now, my return statement, and deliberately I've done this, is just one line. So we could actually use an implicit return, which means that when this is compiled down to ES5, it will be converted and it will add the return keyword and these things that we need. It will convert this down to proper JavaScript. But using this implicit return, we can actually do something a little bit like this. So you can see how this is cleaning up the code base very, very nicely. And this is one of my favorite features with the arrow function, is that implicit return. And this is the exact equivalent to doing this. So we have that curly brace return statement. If it's just a one-liner, we can get away with doing something like this. So I hope this is a good introduction for you. And there's one more thing that I want to also cover. We'll create a pizza on its own, and we'll just add a property. We can say that this one's going to be the Blazing Inferno, and we can say we want to get the name. We can then supply this a function. Now there's also a ES6 version of this, which we'll cover as we continue through this chapter. But essentially, if we did console dot and log, and we did this, this would give us a reference to the pizza, because what we would have to do is say pizza dot, and then you can see here that we have that get name. So I can call this. What I'll do is just demonstrate this to you, and we'll compile this out with TSC as well. And then we'll run node, and we'll see that we have our name of the pizza, and we also have the get name. So this is referring to this. You don't have to worry about undefined. We're going to console log this momentarily. So the undefined is referring to here because we're not returning anything. And this second console here is the this value. So this is pointing to our object at this moment in time. But let's say that we had a set timeout. They typically look something like this. And we can just say 100 milliseconds. And inside of there, we'll say console log. And we're going to console log this. So let's again run TSC and just see the difference here. So we'll run node. And you can see that if I need to even expand this, that the this keyword is pointing to a completely different reference. It's pointing to the set timeout, not this object that we care about. So typically what we would have done in the past is done something like const self equals this, and then console log self. But with an arrow function, we can get around this. We can say that we want to simply add the arrow at the end, which means that we don't need to do this. And just to confirm this, I'll console log this out as well. We'll do TSC, and then I'll expand this again so we can see that this is working. So here we have the set timeout, which pushes it to the end of the call stack. So we get that undefined first, and 100 milliseconds later, we then get the name with the get name. So what we could then do at this point is say console log this.name, or we could do something with this.name. And this is just giving you an example of how to mitigate this issues with an arrow function and the benefits that it provides us. So the way that this works is by the arrow function. What it essentially does is ignore the scope. It doesn't create a new scope. It's just not binding any this value. It's ignoring it altogether. Now you can think of it as it kind of inherits the scope. It's not technically correct, but it essentially doesn't bind any this value. So it will just use whatever this value is available. So to complete this off, we want to get the name. What we can actually do if we wanted to is use the arrow function here and say this.name, and we can get rid of this and our final line. So let's run this TSC, and we'll also run node. So you can see here that it's pointing to undefined because we do not have a this context. What we would need to do to fix this is pizza.name, and we can just confirm that with TSC, and then we can compile that with node. So this works nicely. What we would need to do, and this is because the arrow function is placed on the object itself. It's pointing to a this context that doesn't work. However, if we went and used that function, and we then used the actual keyword here, we could then say console.log, and we can say this.name, and we can save that out, compile that with TSC, and then run node. So you can see here that we have Blazing Inferno, and that's working as you'd expect. So these are kind of the differences between the old function, if you want to call it that. And don't forget that you can still perfectly use the function keyword. It's quite frequent, and I actually like this approach still. You can create these functions, and we might have some kind of create pizza function such as this. So this is perfectly acceptable. Don't just try and create everything as an arrow function. Only use them when you need them. So we just covered arrow functions. So what I want to talk about is how we can use another feature, and we can also use this in an arrow function as well. So let's talk about default function parameters. These are a new feature in JavaScript. So let's say that we want to create a function, and we're going to call this the multiply function. We might have parameter A and parameter B, and we can say return A multiplied by B. This is nice and easy. We can then console.log our multiply function, and then we can pass in perhaps 5 and then 25. Now it might be that we actually do something in a real world app that's a bit more complex than this, but let's say that if we don't supply a second argument, we can actually add a default. So our multiply function might increment things at a rate of 25, and it might be that we just want to override it at particular times in our app. So let's actually go ahead and remove this, and I'll open up my terminal. We're going to run TSC, and then we can run node dist app.js. So you can see here that 5 times 25 is 125. So how is this working? What it's essentially doing is something like this, which is a common pattern. We'd say if there is no b argument, so if b does not exist, then we could say b equals 25. This is pretty much what this is doing. If we do not supply an argument, we're essentially setting a default. So we can confirm this because we can again create a second function, and we're going to pass in 35. So we're changing that, and we're overriding the default function parameter. So let's go ahead and run TSC again, and then we'll go ahead and run node, and we get 125 and 175. So this is a small introduction. It doesn't need to be much more complex than this. You can use them in any shape or form that you like. And as we continue with TypeScript, we'll also learn how to type these default functions and provide optional function parameters as well. I'm going to call these the object literal improvements. These are really, really nice when it comes to working with either ES6 or TypeScript. So first things first, what we're going to do is create a constant called pizza, and we're just going to give it a name. We're going to call this pepperoni to keep things simple, and we can just give it a price of 15 as an example. Now let's also create another constant. We're going to call these the toppings, and we're just going to add that one topping of pepperoni. Now what we're going to do is actually create a new object based off of these objects. These are common things that you'll be doing every day when dealing with JavaScript applications. So the first thing I want to show you is creating a new object based off of other objects. Now it might be that we are inside of a callback function to submit the order and place an order for the pizzas, and we might merge the toppings with the pizza and then send that off and get a custom price if we want to add or remove toppings as an example. So typically this is something what we'd do. We'd do pizza, and then assign it the value of pizza, and then we'd say toppings and assign it the value of toppings. So we create a new object with a property of pizza, and we take this and assign it down here, and we do the same with our toppings. Now in ES6, we can in fact go ahead and just remove that, and we can remove that altogether. We could, if we wanted to, actually just put this on one line as well, and that will create the exact same object as what we just demonstrated with the pizza and the colon, and then giving it a value of pizza. So this is one of my favorite things with TypeScript and ES6, and it's a shorthand syntax for creating a property based off of the value of another property. So let's go ahead and just confirm this. We'll say console log order, open up our terminal, compile this out with TSC, and then finally run node. And you can see here we have our new object. We have pizza with the name of pepperoni, and then we have the toppings with our array of toppings. So this works really nicely. Now this syntax works exactly the same when we do things perhaps inside of a function. We could have function create the order, and inside there we're going to return a new object. So we could say pizza and the toppings, and we could create the order, pass in our pizza, pass in our toppings, and save it out. So this will do the exact same thing. It's up to you how you want to compose these. Now there's also a nice benefit when it comes to using a function on an object. So what we can actually do, and what we typically can do, is do things such as get the pizza name, and then we assign it a function, and we could do return this dot name. So this is completely valid. We can do console.log the pizza dot get name. So we'll save this out, and I'll just open up the terminal, compile this out to show you where we're going to start from. So here we have the pepperoni that's successfully been logged out as that pizza's object name. Now this is one of my favorite pieces because it saves us some boilerplate, if you want to call it that. Again, this colon and function name, because we are in a new ES6 literal of an object, we can actually just delete this whole piece together. So we can simply create what looks like just properties, and then if it's a property with a value, we give it a colon. If it's a property that's a function, we just put this function brackets before it. We don't need to do things such as create arrow functions, or we could do stuff like this. This is completely valid, but it defeats the object of using it. So ideally we should use something that looks a little bit like this, and just to confirm that this works 100%, we can compile TSC and then run node again, and we have pepperoni that's just been successfully logged out. So these are some of the improvements, and we'll be using some of these approaches that we're talking about in this chapter further on in the course. So we're going to learn about something which is really, really nice as well, called the rest parameter. Now it's a new syntax which allows us to essentially pass any number of arguments into a single variable. So for this, what we're going to do is create a function, and we'll call it the sum all function. We want to add everything together. So what we could possibly do is pass in an array of numbers, but it might be that we want to just pass in something else. So first off, we'll create our sum all, and we could say 1, 2, 3, 4, 5, 6, 7, 8, 9, and finally 10. So I've added these inside of an array, and what we can actually do inside here is then say array.reduce, and what I'm going to do is add previous and next, followed by an arrow function where we simply accumulate and add the previous value to the next value. So let's create a quick constant of sum, and then down below we can log out the sum. Now what we actually need to do, because we've changed this, is return. So once we're done with this, we can open up our terminal, compile out to TSC, and then we want to run this with node. So this, adding all the numbers together, equals 55. Now let's say that we had an indefinite number of arguments. We have 1, 2, 3, 4, we have 10 arguments here, and we want to simply grab hold of all of them at once. What we don't want to do is say number 1, number 2, number 3, and so forth. What we can do is use a rest parameters to essentially get them all as a single value. And this we can say ... and then ARR, short for array. So this, in fact, will take all of these arguments and put them into a single argument by using the rest parameters. Now you can kind of imagine this as give me the rest of the arguments, the rest of them. We want all of them. Now, this doesn't stop us also passing in a first argument and then perhaps logging it out as well. So just to demonstrate the difference, we could put hello as the first argument. If we wanted to just then sum everything here, what we can do is just put the message as the first argument, and then we can continue and use that rest parameter elsewhere. So let's log our message above, and we'll say console log message, save this out, and we'll run TSC again, and finally node. So we then see how we can use that one argument, and we can also use the remainder of the other arguments. Now you might be thinking this is slightly different to the arguments object. This is a reserved keyword in JavaScript. This is why it's gone blue. So the arguments object is slightly different. So let's compile it out and take a look. When we run this with Node, we will see an object map of all of the arguments. And it's typical that we might do something like argument 0 to get that first argument. We don't need to do this anymore. We've got rest parameters at our disposal, and these are a super addition to TypeScript and the ES6 language. What I want to show you is the array spread operator. Now we just looked at the rest parameters, and the array spread operator is not too dissimilar. So let's just say that we have a constant of toppings, and we're going to say that we have bacon and we have chili available, and we also have some new toppings. The new topping is going to be a pepperoni. Now if we want to merge both of these arrays, and this ties in nicely with immutable patterns. If you're dealing with immutability in JavaScript, immutable data structures, then these are the types of things that will interest you. So how do we go about saying const all toppings? How do we go about merging them all together? Now it might be that you've previously in the past used the concat method, where you concatenate things together. But with the spread operator, what we can do, and this depends on the order of how you want to do it as well, we can say ... toppings, and we can also say ... new toppings. So what this is going to do is spread both of those array values into a single array. So we'll end up with one array with 3 values inside. What it doesn't do is keep the reference to the toppings and the new toppings. It creates a copy, and it puts that copy into a new array. So if you're dealing things like immutable update patterns or immutable objects and arrays, this is what you'll need to do. So let's open up our terminal. What we'll do is run TSC, and then we'll just demonstrate how this works. We can then go ahead and run our node, and there you have it. We have our first toppings, which is being spread into our brand new array, followed by our second toppings, and you can see that we just have that pepperoni at the end. This is also really nice because it makes it super simple for us to modify the order without worrying about JavaScript methods like concat and slice and all these different types of things. So let's just confirm that this is how we can approach it and swap things around. So again, we have our new array, we have pepperoni at the beginning, and this is a real nice example to demonstrate how we can use the spread operator with an array.